Hello, Lokesh. How are you? Hello. Hello. Is it audible?
Yes, sir.
Right. Is it audible?
Yes, sir.
Right. Just let's wait for a minute and then we will start. Okay.
Okay, sir.
Okay. Chलिए, let's start now. So we have discussed up to the different type of forces, isn't it? The spring force was the last one we have discussed, and then we were discussing about the equilibrium questions. That if a body is in equilibrium, then what will be the forces acting on that? Okay, now. So that is what we discussed in the last class. Okay, right? Please tell me, clear up to this?
Yes, sir.
Right. No one is still there. I will
Sir, no
just
one
put a
joined.
message. Okay. Yeah, that's what I'm saying. If they wanted the leave, they could have already informed it. Now, chalo, I will put. Let's start. Let's continue now. Okay. Okay. So up to equilibrium we have discussed. So what is the condition required for equilibrium? So for equilibrium, the net force should be what? It should be zero. Okay. Right. And if it is in acceleration, then what will happen? Net force will be equal to what? The mass into acceleration. Okay. So till now we have only discussed the questions where the body was in equilibrium. Okay. See that? Okay. Now, ideal pulley, ideal object with the help of free body diagram, we have discussed the questions. Okay. Now. So that was for the equilibrium of the body. Equilibrium of the body, what is needed? Net force should be equal to what? Zero. Now let's discuss about the accelerated motion, okay? Or for acceleration of particle, what is required? For acceleration of particle, what is needed? For acceleration of particle, net force should be equal to what? It should be equal to mass into acceleration. Sometime what will happen? One direction we have the equilibrium and other direction we have the acceleration. That is also possible, isn't it? That the motion is or the situation of the objects are in such a way that one of the direction we have the equilibrium and other direction we have the acceleration. Okay. So in that situation, what we will do it? Let's take help of an example and try to understand. Okay. See, in this example, what is given to us? In this example given to us, let's say something like this. There is one block of mass 10 kg, and there is a behind also there is another block of what, 5 kg, and we are applying the force on this block of what, the 60 newton. Okay, we have applied what, a 60 newton force here. Now in the question they are asking, find acceleration of blocks and normal force acting between the block. Okay, and normal force acting between the blocks. Okay, understand the question? Two things we have to find out in this question. What is the acceleration of each block, and what is the normal force between the blocks? Okay, so please tell me what we should do it in this question. See, can we start with drawing the free body diagram of each block? You see that 10 kg block, if you draw the free body diagram, what forces will be acting? 100 Newton mg will be acting, isn't it?
60 Newton.
Next, yeah, there will be one normal acting, let's call it N1, because of the ground, and there will be one force acting here, that is the 60 Newton, and there will be one more force, isn't it? The normal due to other block will be also acting, isn't it? There is two contact for the 10 kg, na? One with the ground and other with the block. The one normal due to ground I have represented as N1, other normal due to block I have written at what, N. Okay. Now we will draw what, the free body diagram of 5 kg, and then we will write the equation. So for 5 kg what will happen? Weight will be acting is 50 Newton. Ground will be applying the normal on that one, N2. And isn't it the 10 kg will be applying a normal on the block? So which two forces are action reaction? Can I say this normal and this normal are the action reaction pairs? Please check it now. Right? Now let's write the equation. Let's say acceleration of these two blocks are what? A and A. Now you see, if this motion is happening, is this motion is only happening along the horizontal direction? There is no acceleration happening in the vertical direction. Why? Vertical direction, it is in contact with the ground, isn't it? So vertical direction, we don't have any acceleration. The only acceleration we have is in the horizontal direction. So what equation we will write it? Tell me. For the 10 kg block and for 5 kg block, let's write it separately. For for 10 kg block, can you tell me what are the equations we will write it?
60
For 10 kg
minus
block,
N
yes, 60 minus n should be equal to mass into
10A.
acceleration, है ना? And n1 should be equal to how much? Can we say n1 should be equal to 100 Newton?
Yes, sir.
Because here you see horizontal we have accelerated motion, and vertical what we have? Vertical we have equilibrium condition. Okay.
Yes,
So
sir.
for 10 kg block, can I write it? N1 should be equal to 100 Newton. That comes from where? For equilibrium, because vertical direction we have the equilibrium. Next, 60 minus n should be equal to mass into acceleration. Let's see the equation for the 5 kg block. For 5 kg block, what we can write it? Can I write it? N2 should be equal to 50 Newton again. है ना? Because of what? Because of the equilibrium condition. Okay. And the second one, n should be equal to what? Mass into acceleration. That is our second equation. Now, if you look at the equation 1 and 2, then we can simplify and get our answer. So 1 and 2, if we add it, minus n plus n got cancel out. 60 equal to 10 plus 5, 15a. So that we have acceleration equal to how much? 4 meter per second square. And if acceleration is 4 meter per second square, let's put it in the equation 1. So if you put the value in the equation 1, what it will become? 60 minus n equal to mass into acceleration. That gives us n equal to what? 60 minus 40, 20 Newton. So here in the question, what are the all things they ask in the question? We have calculated. What are the things they ask? What is acceleration of these blocks? That is what we have calculated, right? Next, what is the normal reaction between them? That is 20 Newton. And what is normal due to ground on 10 kg and 5 kg? So on 10 kg it is 100 Newton and on 5 kg it is 50 Newton. So these are the things they ask in this question. Understood? A same question, they can put it in a different way. How? See, look at this question. In this question, I'm going to take everything same. Okay, means this is the 10 kg block and 5 kg block. Instead of keeping it in contact with each other, I'm going to put it what? Connected with the help of a string. And this time, I'm going to apply a force of, okay, 100 Newton on the 5 kg block and what angle? At an angle of 37 degree. Understand the question?
Yes, sir.
Just let's make sure that it should not get lifted. 100 cos 37 is 4 by 5, 80 and 60. No, we have to reduce this force. Otherwise, this block will be lifted. Let's make this force as what? 60 Newton. Don't take it 100 Newton. Otherwise, you will see this 5 kg block will be lifted. Take it as the 60 Newton. Now, again, my question is same. What are the things we have to find out in the question? Find, first thing, acceleration of both block. Acceleration of both blocks. How much are that? And second thing, tension in the string connecting. Okay, tension in the string connecting the block. Okay, connecting the blocks. What is the tension in that string? That we have to find out. Another thing, what is the normal applied by the ground on the blocks also? That is also there asking in the question. So please tell me how much will be the coming answer. Will you try now?
Yes, sir.
Right. So masses I have taken same, and instead of keeping them in contact with each other, what I did, I connected these two blocks with the help of what? An ideal string. Keep in mind, this is what kind of a string? It is an ideal string. Ideal string means what? Massless and inextensible string. We call it as what? The ideal string. Okay. Please tell me how much it is coming. Only you are there, Lokesh.
Sir, Ramcharan, sir.
Okay, Lokesh joined and now he is not there. Charan, you are there. Wow. Okay. Chaliye, let's continue. Okay, I think he will join back. Chaliye, solve the Charan. Tell me. Trying this one?
Trying, sir.
Right. So again, what we should do it? We should start with drawing the free body diagram. Understood? We should start this question again with the help of what? The free body diagram. Let's first draw the forces acting on these two blocks. Okay? Because once we know what are the forces acting on these blocks, then what we will be able to do? we will be able to write the equation. If it is equilibrium, we will write the equilibrium condition. If it is in acceleration, then we will write the acceleration equation. So let's start with what? Start with the free body diagram. Okay. See, exactly similar free body diagram will come. What we got it in the last question. Tell me what forces will be there? Will there be one mg acting downward?
Tension.
Tension. One normal will be acting due to ground. One tension will be acting. Tension is pulling type now. That's why it is drawn what? Away from the body, right?
Yes,
Tension
sir.
is along the string and away from the body. So these are the only three forces acting on the block, and it has some acceleration, something A, which we have to calculate it in the question. Now let's go to the 5 kg block. 5 kg what forces are acting? 50 Newton is the weight, normal N2, and this is the tension T. Can I say that these two tension are the action and reaction force? Please tell me, this tension and this tension are the action and reaction force, equal and opposite, acting on two different body, isn't it? And there is one more force. What is that? 60 Newton. है ना? Please check it and tell me, have we drawn all the forces carefully? This angle is 37 degree. And this has what acceleration? Same acceleration A. They cannot have different acceleration, isn't it? Why? Because they are connected by the same string. So they should have what? The same acceleration for both of them. Now, before solving, can I take the component? So what is this component will come? 60 cos 37 will come. And what is the other component will come? Other component 60 sine 37 will come, right? Actually, let's write the equation now for both the blocks. For 10 kg block, can you tell me what is the equations you will write it? For 10 kg block, tell me, can I write it? N1 should be equal to 100, equilibrium condition in the vertical direction, because vertical direction this block is not moving, the block is only moving along the horizontal plane, so that's why vertically we have written equilibrium condition. Next, tension is the horizontal force, that should be mass into acceleration. Please tell, is it the first equation clear? Next, for 5 kg, let's write the equation. For 5 kg, can I say that N2 plus 60 sine 37, should it be equal to 50? Please check it. Please check N2 plus 60 sine 37. Are these two forces in the upward direction? That must be balancing what? The downward direction, isn't it? Because in the vertical direction, we don't have any kind of acceleration. So vertical direction, it will be balanced condition. And horizontal direction, what I will write it? 60 cos 37 minus t. Is it the net force? And net force should be equal to what? Mass into acceleration. That is my second equation. Please tell me, can we solve these two equations 1 and 2? Check it. Can we
Yes,
solve the
sir.
equation 1 and 2? And now we will get our answer. Okay. So if I want to solve equation 1 and 2, is it not better? Let's add 1 and 2. So plus t minus t gone. 60 cos 37. What is cos 37? 4 by 5. Okay. Cos 37 is how much? 4 by 5. Sin 37 is how much? 3 by 5. So 60 into 4 by 5, 10 plus 5, 15a, isn't it? So what is the acceleration we are getting? So acceleration, if we are calculating 5 into 12, the acceleration is coming 12 into 4, 48 by 15 meter per second square. So this is the tension we got it. Sorry, acceleration we got it. Now if I use the equation 1, now if we use the equation 1, what I'm getting? tension equal to 10 into 48 by 15, right? 5 into 3, 5 into 2, 3 into 16. So 32 Newton we got it as the tension in the string connecting both the block. That is the tension we got it. N1 is directly 100 Newton. N2, so we will use what? 5 kg block, vertical direction, equilibrium condition we will use it, and we will get the N2 value. Okay, so N1, N2 we got it, tension we got it, and acceleration we got it. These are the four things that can be asked in the question. So please tell me what we discussed here. Understand these two questions? These two questions are based on what? The acceleration of the block. Understood?
Yes, sir. Yes, sir.
But acceleration of the block, na, sometimes they will give you a question. Right. This is the N1 we got it. Right. We can continue with this equation. And if we simplify this equation, we will get the N2. How much N2 will come? 50 minus 11 is 3 by 5. So 5, 12 minus 3, 36. So 14 Newton we are getting as the N2. So these are the things they can ask you in this question. Please tell me, clear this question?
Yes, sir.
Right. Okay. Let's discuss the next example now based on the acceleration. Let's discuss few examples on the acceleration, and then we will go for the another type of force we need to learn is called the friction force. Okay, in the friction force we'll discuss about the static and kinetic friction, but today we will finish it all type of questions of the accelerated motion. Okay, clear? In this question given, this question right now I am discussing here without friction, and later when I will discuss the friction chapter, I will again discuss the same question for what? Rough surface. Okay, a simple question is given to us that a block of mass 10 kg is given to us, and that is kept on an inclined plane of inclination 30 degree. Okay, and length of incline, or this block has to travel how much distance? Let's say it has to travel the 20 meter. 20 meter is along the incline given to in the question. Okay, which direction it is given? Along the incline. Acha, please keep in mind whenever you will get this type of question, sometime they will give you the length along the incline, and sometime they will give you the height. Means tell me, if I give you the height, can you convert this height into length of incline? Please tell me, using just right angle triangle. Please tell me. This is the H and this is the L, and this angle is theta. Can it be converted H, L and theta? Check it. Can I write it? Sin theta equal to
Yes,
H by
sir.
L. है ना? Sin theta equal to what? H by L. So please look at the question. Did they give height of the object travel, or did they give length of the object travel along the incline? Okay, just be careful about which data is given in the question. So here they are asking in the question, find first thing. This inclined plane is a smooth one. Okay, this is a what kind of incline? Smooth. Smooth means what? Smooth means frictionless incline given to us. Okay, to find first thing, acceleration of block. Acha, can you tell me acceleration of block will come here? Which direction it will come? Which way the block can move? Can it move
Along
only
the
along the
inclines.
incline? Yes. To find acceleration of block along the incline. Even though if they don't mention it, we will always find it what? Along the incline. Second, time taken by block to reach the bottom. Okay, time taken by block to reach the bottom. That is the second thing they are asking in the question. And the second thing is what? Time taken by block to reach the bottom. Third thing we have to find out, when it will reach the bottom, it will have some velocity starting from rest. Okay, starting from rest. So when it will reach the bottom, it will have some velocity. Understood? So we also have to find out what is the velocity of the block when it reaches the bottom. Okay, the third part, velocity of block when it reaches the bottom. Okay, when it reaches the bottom, that's what they are asking, starting from rest. To solve this question, isn't it the first thing I need is to calculate their acceleration? And if I know the acceleration, then rest all other things we can be able to find out, isn't it? V equal to u plus at, we can apply it. S equal to ut plus half at square, we can apply it, right or not? So that means the first important thing is to find the acceleration. Can you tell me how much will be the acceleration of the block? This is how the block is kept on the inclined plane. Na? Please tell me what forces will be acting. Is that going to be mg acting?
mg sin theta है.
Mg will be acting and one more will be normal acting. These are the only two forces acting on the block. So to calculate the acceleration, should I first do one thing is to take the component? Please tell me, isn't it? And here we will take the component which direction? Here we will take the component along the incline and perpendicular to incline. Why? Because along the incline, acceleration we will calculate. Perpendicular to incline, equilibrium will be there. To see that if this angle is theta, this is the vertical line. So this one will be 90 minus theta and this angle again becomes theta. So what is this mg component? Mg cos theta, and what is the other component? Mg sin theta. So if you write the equation, can you write it? N will be equal to mg cos theta from the equilibrium of the block. And what mg sin theta will do? So can I write it? Mg sin theta will be equal to mass into acceleration. So what is the acceleration we are getting? G sin theta. So irrespective of the mass of the block, please keep in mind, irrespective of the mass of the block, if a block comes down an inclined smooth plane, okay, irrespective of the mass of the block, if a block comes down a smooth inclined plane, what will be acceleration of the block? Acceleration of block along the incline is always going to be, along the incline is always going to be how much? G sin theta. The condition is what? Smooth inclined plane. Okay, along a smooth inclined plane, it will be always equal to how much? G sin theta. So now just put the value. G is 10, sine theta in the question is given 30 degree. So its acceleration is 5 meter per second square. Now, once we got the acceleration, can we find out what is the time taken, what is the velocity? So for time taken, should I use it? S equal to ut plus half at square? Please tell me. Displacement is 20 meter, initial velocity 0, half, acceleration is 5, and t square. So what is the t we are getting? 40 by 5. And 40 by 5 means 8, square root of 8. That means 2 root 2 second we got it. This is the time taken by the block to reach the ground. And once we know the time, can we use the second equation? V equal to u plus a into t. The velocity we have to find out. Initial velocity 0. Acceleration is 5. And the time we have calculated is what? 2 root 2 second. So that means what will be the velocity of block when it reaches the bottom? So the velocity of block is going to be 5 into 2 root 2. That means 10 root 2 meter per second. That is going to be our velocity when it reaches the bottom. Understood? Please tell me. So all these questions you are seeing what? One direction it is acceleration. One direction we have equilibrium. So the direction in which equilibrium condition is there, in that one apply the equilibrium condition, matlab net force equal to 0, and the direction in which we have the acceleration, we should apply net force equal to mass into acceleration in that direction. So please tell, understood what we discussed till now?
Yes, sir.
Right? So these are the cases of what? Equilibrium and acceleration. Okay. Sometime we will have the pulley block system. An example based on what? The pulley block system. Okay. Chaliye, tell me, let's take one example. This is a fixed pulley, okay? Massless pulley given to us. And in this question, what is given? Ideal. What kind of pulley? Pulley is ideal. What kind of spring? Spring is ideal. What kind of thread? Ideal. All of them are what? Ideal pulley, ideal string, ideal spring. Okay. And here the masses are given 4 kg. And here the other side, the mass is given as 2 kg. Okay. Here we have to find out the three things. Find first one, acceleration of both the blocks. Okay, first thing we have to find out is acceleration of blocks. Blocks means both blocks. Second thing, tension in the string connecting. Okay, tension in the string. And the third one, reading of spring balance. Sometimes they will give a fancy word. What is the reading of this spring balance? Nothing but reading of a spring balance is nothing. It's just the spring force. Okay. What is the reading of a spring balance? Reading of a spring balance means what is the spring force developed in the spring? That is called the reading of a spring balance. Okay. Same way, there is a weighing scale also. Na? What is the reading of a weighing scale? What is the normal the weighing scale is experiencing? That normal is nothing but the reading of a weighing scale. Understood? So reading of a spring balance they are saying, or they are just asking what is the spring force. Okay. To find reading of, they will use the word like this just to confuse you. Okay. What is the reading of spring balance? Reading of a spring balance is nothing but what I am asking actually here, spring force. Okay. That's it. Nothing different I'm asking in the question. Just tell me what is the spring force. That is the reading of what? The spring balance for us. Okay. Chaliye, please start this one by drawing the free body diagram of 4 kg and 2 kg block. Okay. Let's start with the free body diagram of 4 kg and 2 kg to continue this question further. Okay. Will you draw the free body diagram of 4 kg and 2 kg first?
Yes, sir.
Let's start with the free body diagram of the 2 kg and 4 kg first. Okay. So 4 kg, what forces will be acting? So on the 4 kg, can we say there will be a tension pulling it, है ना? Tension is always along the string, but always away from the body because tension will always try to pull the body, है ना? And there will be one mg force, which is the 40 Newton. Now tell me, these two blocks are connected with the same string, na? Same ideal string. And this string is passing over what kind of pulley? An ideal pulley. So can I say this string here to here? Can I say same tension will be there from this point to this point? Every point on the string is going to have what? The same tension. So that's why if I draw the free body diagram of 2 kg block, can I say here tension is T and here is 20 Newton? Please tell me, clear up to this? Why did we take same tension throughout the string? Because we got the string as an ideal one. We got pulley as ideal. So that's why both side of the pulley string is there and string contains having the same tension. So now if you write the equation, what you will get it? Here acceleration is A and here acceleration is. So tell me, what is the equation? We will write it for the 4 kg. Here no need to take the component in the question, isn't it? Here the component is not required. Why so? Because the forces are only in the vertical. All the forces are vertical. There is no horizontal. There is no force at any component at any angle. So no need to take the component here. Directly we will start with the equation. The 4 kg, what I will write it? Will I write it 40 minus T? Is it the net force? Check it. 40 downward, T upward. The net force will become 40 minus T. Should that be equal to mass into acceleration? First equation. 2 kg block, T minus 20 equal to 2 into A. Net force equal to mass into acceleration. Let's solve equation 1 and 2. Can we add equation 1 and 2? Minus T plus T gone. 40 minus 20. The 40 minus 20 is 20. 4 plus 2, 6A. That means what is the acceleration we are getting? 20 by 6 or 10 by 3 meter per second square. So that means what? The 4 kg block is going down with 10 by 3 meter per second square and 2 kg is going up with the same acceleration 10 by 3 meter per second square. Now you can use it either the equation 1 or 2 and then we will get the value of tension also. So 40 minus T equal to 4 into what is the acceleration we have calculated? 10 by 3. So what is the tension we are getting? 40 minus 40 by 3. So what we have? 80 by 3 Newton. We have it as the tension. Okay. Okay, let's.
S-
Hello.
I have got a network issue, sir. So I joined.
Okay, okay. Right. So this is where we were right now. Okay. We were calculating the tension in the string. Okay, now tension in the string. So see that up to this
Yes,
understood
yes,
where you were till now? Free body diagram and equations part got it?
yes, sir. I got it, sir.
Right. So we got the tension in the string and we got the acceleration of both the block. The next part which was asked, what is the spring force, isn't it? So see that if you look at the pulley and you will find a very interesting thing here happening with the pulley. See that on the pulley, is it this side there is a tension T acting? And is there a tension T acting the other side? So what will be force on the other side? So the pulley is always in equilibrium. Net force on the pulley, we will always get it as how much? Zero. So that means if this side tension is T and this side tension is T, and this side we have this spring force. So can I say this spring force is going to be nothing but 2T? Because why? Because massless pulley, okay? For what kind of pulley? For a massless pulley, for what kind of pulley? For massless pulley, F net should be always zero. Net force acting on a massless pulley is always zero. So that's why if downward force is T and T, then upward force should be also what? 2T. So that means here, what is the spring force will come? 2 into T will come. And what is the tension we have calculated? 80 by 3 Newton. So 160 by 3 Newton is the spring force we got it. Understood? So please keep in mind whenever you will see a pulley, what kind of pulley? Ideal pulley. What kind of pulley is that? If the pulley is ideal, then both side of the pulley means upward and downward. Both side of the pulley, we will always have what? The same amount of force. So the net force acting on the pulley should be always how much? It should be always zero. Understood? Net force acting on the pulley should be always how much? It should be equal to zero. Understood? Let's discuss one last example. Okay. And then we'll go for the next type of forces, which is going to be the friction force and the pseudo force. Okay. These are the two forces we need to learn it still. Okay. Now we have discussed about the normal mg tension, isn't it? Spring force, how to calculate them, but we have not yet calculated the friction force in any of the question. Okay, so we'll do that also, but before that let's discuss about one more example on the acceleration part. Okay, in this example what is given to us? Okay. Here in this example what is given to us, there is a horizontal table. Okay, a smooth table is given to us. There is one block here connected, another block connected. Let's make a little bit bigger table here, like this. Okay, and then there is a ideal pulley here, and this ideal pulley is connecting one more block. Okay, something like this kind of situation is given to us. The masses, I'm going to take it. This mass is 2 kg, this mass is 4 kg, and this mass is given as 6 kg. This is an ideal pulley given to us. Now, here you tell me how many strings are there? One string or two string? Please tell me.
Two strings, sir.
There are two strings. So black string will have same tension throughout, isn't it? And this another color string, the blue string will also have the same tension. But these two strings are going to have two different tension. Understood? But if I look at the black string, every point I will have the same tension, isn't it? So let's find out three things in this question. What are those? Find first one, acceleration of blocks. That is same, isn't it? Because all are connected. Whatever the first one will move, the same the second one has to move. But here tension in strings are going to be different. Tension in both strings is T1 and T2. So that we have to calculate it separately. Can we start with the free body diagram of the blocks? 2 kg. One normal due to table, one weight, and one tension T1. And it has acceleration something A. 4 kg block. 4 kg block, you will see weight is 40, normal due to table N2. Black string is applying a tension T1, and that blue string is applying the tension T2. Please tell me, understood? And one more block is there, the 6 kg block. What forces are acting on that? The tension T2, weight 60. That's it. What is the acceleration of this one? A downward. What is the acceleration of this one? A towards right. Please tell me, is the free body diagram of all the three blocks clear? Because once the free body diagram is clear, then we can write the equations. If I ask you what are the action reaction, this T1 and this T1 are action and reaction. Similarly, this T2 and this T2 are what? Action and reaction. So if they are asking which of them are action reaction pair, we can identify. Now let's write the equation. For 2 kg, what I will write? For 2 kg, I will write N1 equal to 20. That give me straight away the answer. And the second one, I will write it. T1 equal to mass into acceleration. Let's go to the 4 kg now. 4 kg, what I have? N2 equal to 40. That is straight away we solved it. Next, T2 minus T1 equal to mass into acceleration. Second equation again useful one. For 6 kg if you look at, will I write it 60 minus T2 equal to 6 into A? That is our third equation. Now if you look at the equation number 1, 2 and 3, you will see that we have three unknowns in the equation number 1, 2 and 3. T1, T2 and acceleration of the blocks. These are the three unknowns. We have it in these three equation. We can solve it. How we will solve these three equation? We will add equation 1, 2 and 3 plus T1 minus T1 gone plus T2 minus T2 gone. So 60 equal to 2 plus 4 plus 6. 12A we have. So what is the acceleration we got it? 5 meter per second square. And next thing what we have? T1. The first equation gives us the T1, right? T1 equal to 2 into A. So T1 we got it as the 10 Newton. Second equation gives me what? T2, है ना? So from second equation if you apply, what we will get it? T2 minus T1 equal to 4 into A. So T2 we are getting 20 plus 10. 30 Newton we got it. Understood? So these are the situations where in one direction we have the equilibrium, the other direction we have the accelerated motion. Okay, please check me. So whenever you see a situation where one direction is the equilibrium, other direction is acceleration, so we should apply the equilibrium condition for the given direction and then accelerated condition. Please tell me, clear up to this?
Yes, sir.
Right, so tomorrow onward again we will have the uh, electromagnetism class, right? So let's continue it from there. Please tell, are you solving the questions, completing the questions or not?
Yes, sir. Solving, sir.
Right. Okay, able to solve the questions now?
Yes, sir.
Right. Please solve the questions. If any doubt or difficulty is there, ask it in the class also, okay?
Okay, sir.
Right. Okay, let's meet it tomorrow again then. Right then, I will share the notes, okay? And please continue with the questions, okay?
Okay, sir. Thank you.